I have a new watch, or at least a relatively new watch, that actually acquired it. It was the holiday gift at Google, and I just started using it finally after deciding that, gosh, everyone at work's using them. So, and just around the time I started using them, a number of other folks have sort of stopped using them. But anyways, it talks over Bluetooth to your phone, and it has a lovely power-saving thing where it, the display goes into sort of a black and white mode and display some sort of watch face. But the cool feature is, of course, OK, Google. Come on. No. Demo fail. See, it's a terrible feature. OK, Google. Come on. It was a good try.
Who's a good watch?
Who's a good watch? Come on. Hello?
You say Siri.
Yes, ostensibly there's some sort of chip that does does recognition just of that phrase. Okay, Google. No, it's just not wanting to work.
So you don't need network access for it to respond to it.
Yes, that's ostensibly the deal. There's some little mini a recognizer that they come on, it's completely dead. Oh, okay. Okay, well, okay. Anyways, I didn't catch that. Okay. Okay, Google. Silicon Valley Fourth Interest Group. Yay. SV Fourth Day. Blah blah blah. Okay, so it does various things, and you can bring up your search results, and the UI is structured around these sort of like little paging things, and then you swipe the way to the right. There's some elaborate sort of gestural whatnot to it, but I haven't figured them all out. I think double tap brings up the menus, and you slide them around and whatnot. There's apps you can install, but they're not the same apps as on the phone. They have to be kind of aware of the watch. And at some point, if I get very industrious, maybe I'll try to write one myself. But I have not done so as yet. So.
Wrist IQ.
Ooh, hey. So yeah, I have no idea what the actual display capabilities are, but given that it has the phone to lean on, perhaps I could have the phone do more of the work. So. For the Pebble, at least, yeah. So, anyways, I brought it up. I'll let you know. The main thing that's interesting about it is that because it vibrates when you get notifications. It kind of makes you. I am the kind of person where if my phone vibrates, I'll just ignore it. So, whereas your wrist vibrates, it's like, oh, what's that? Let me go look. I've found so far that generally I'm getting in the habit of just swishing it away, whatever it is. But occasionally it'll actually be something interesting, and I'll be a little bit more situationally aware.
The feeling that your phone is vibrating or your watch is vibrating even when it isn't.
Yeah. The other weird sensation. Yeah.
Oh, all the time.
Sometimes I'm not wearing a shirt with a pocket here. I can feel my phone.
The other weird sensation is that the phone will vibrate, and moments later the wrist will vibrate. So there's this sort of reconfirmation of yes, in fact.
I had that with the Fitbits too.
Yeah, it's just like it's like, oh, it's going to vibrate. Yep, there it is. So that sort of I suspect that the dual vibration in succession raises awareness. The other one that's nice is that with navigation and the phone, it will show it on the watch. So I'm not like, okay, I got the phone here. I'm too cheap to get the Yeah, well, no, it's nice because it actually, unlike the phone, it actually shows a very minimal set of, it shows you the thing you actually want, which is the next thing you're going to have to do is turn right on this street, which is sort of the, well, yeah. So, anyways.
No, but I think what he said was it shows you the thing you actually want to see. And how does it?
Well, the thing I want to see. The thing I find the most amusing about the other versions of these kinds of devices coming out is that a sizable number of them have circular screens, and so the thing in my head is like, what does the frame buffer look like? And I'm assuming that they're just clipping around the edges, but that's, yeah. You gotta hope.
The arithmetic could get ugly.
Indeed. So that's all I have. All right. So I thought I'd do a quick survey
of exciting things on LinkedIn. I saw that Brad has a work anniversary that's being celebrated on LinkedIn. So congratulations, Brad, on your work anniversary. I see.
That's assuming that he put in his work when he was hired. Many people, in fact, I know many of them, never update LinkedIn.
Well, my feeling about LinkedIn is, where do you work? It's none of your business. Thank you for asking. So that was just a throwaway. This guy, on the other hand, Lars Brinkhoff, has apparently posted in the Fourth Language Enthusiasts discussion group on LinkedIn. Hello, I created a GitHub user to put a star on all Fourth repositories on GitHub. So you might want to look for that if you're interested. And if you're not interested, well, the heck with you. Coming soon on LinkedIn is Dennis's 0th work anniversary, because I guess he's got a new gig. So talk to him about that at the break. Are we ready to go live with Bob? Anytime now.
Am I here? Can you? What do I need?
Oh, I have a voice.
I see. Well, that's like totally awesome.
You have the microphone, though.
Oh, well, I'll give it to you if you care to have it. I will be happy. Can you hear me now?
Bob, are you there? Nope, he's not there yet.
Wait.
Oh, hang on.
Figure that out, I'll play with this.
Did I hear you talk there, Bob?
I guess
Yes.
I needed to click on something. Are you hearing me?
I am hearing you, but no video yet.
No video. Oh, man. What's with the video? Oh, I think maybe it's because I have this camera thing here going. Maybe they're conflicting. Does that do it?
Not yet.
That's
So,
just kidding, Maddie.
emails.
Yeah. Wonder how it goes if I turn off the camera. Turn the camera on. Ah! Okay.
Yes. Cool. We're there.
Yeah.
Kevin is still talking, so we'll go to him for now.
Oh.
No, get it up here and plugged in and all stock ladder. Anyway, Hewlett Packard, oscilloscopes and spectrum analyzers and so forth became Agilent. They eventually became Keysight. And in September, they sent an email around saying, you want one of these back to basics measurement fundamentals? What I really wanted was to download an ISO of the Back to Basics DVD, burn my own, because that seemed to be a lot less trouble. Anyway, I'll put this link up. It was long enough ago so that it may not work. Even if you order one, you may not get one. But the website will make believe it's taking your order. And it's free.
Is it useful?
I guess that remains to be seen. 10 oscilloscopes innovations you really want. It's like the theater near you. How do they know?
Just one simple trick. You get better. It's really nothing personal. I think it just came out of it.
Here's one that's good. Fundamentals of RF design. Well, they don't go
Right.
to TPT.
Get that.
Yay, Bob!
Almost a miracle. Now we're almost there.
Hello?
Oh,
Oh, was that? Am I on?
You are on.
Okay.
Let me put you full screen, and you are alive.
Okay. Yeah, this is the Colorado adjunct here. This is really all about screen, so let me hit the screen share. And, oh hell, what's that? That's wrong. I gotta turn something off. What do I gotta turn off? Let's see. Why did that go infinite? Because I gotta start looking at you. And then go and screen share. Okay. And now, let me go. Here. Got a question? I'll take questions. I mean, consider this. Oh, Stacy? Anyway, yeah, let me go and put down a timestamp, because actually what I'm going to go and sort of concentrate on is actually what the functioning environment looks like, because in lots of ways it's the feedback loop between me and you know, making my machine do things that counts. One of the things is you can't see my keystrokes, but every time you hear I did a Control S to do a save everything, save my environment. And when you start the whole thing, this is what you'll see if you download it, and there are the key instructions and so forth. But let me back over to, you go to my website. Oh, I wanted to go and demo that from directly inside this, inside Cozy. I left the URL, one of the few special keys I've programmed. I recently programmed CF9 to go and Control F9. Okay, except it shouldn't be full screen. Yeah, but anyway, you can go to that page and let me follow one path here. This is the download page, and Cozy is written in Ron Aaron's Riva 4th, which is from a retro 4th background and so forth. And it also, this interface is in IPU, which is a Brazilian open source thing. But I also want to go here, because this gets it around to, you see this I just uploaded, I just fixed this, which is a bug in searching strings that occurs with small strings, and I took it to this level, and this is where, this is actually the definition in Riva 4th source, which you can find over here of it. So if any of you, I put a kludge in on top of it though, which makes the thing work, and you'll see, because before that, just getting to help could bomb on rather random phrases. Let me turn. Are you still there?
Yes, we are. We're just intently listening.
Okay. Yeah, because let me get back. Yeah, leave so I can see some of this. Anyway, let's see. Ready for any questions? Although you need to go and use a mic probably for me to hear it. I could go in any one of a number of directions, because there are all the issues of what the nature of the, I mean, one of the, perhaps some of the most valuable things. Well, let me go through these things that I just put down as notes here. fundamental definition of an object is pretty much given by this, and it's this CS help word, which it'll occasionally bomb. It probably will, and I can show you. As a matter of fact, this display will likely bomb. I think there's some problems in the interface. So again, is you do that before you do anything, including particularly change the size of the window. But in any case, there are two keys, and this is the thing. You can see I can just, this is just, if you will, all text, okay? But if I put the cursor on a line and I hit F6, the F6 key, that will execute it and expect either nothing or a cozy object on the stack at the end, and it will show that result. If I just do Shift F6, that will evaluate the line and just send it to the interpreter, and you know, if for instance it leaves a 0 on the top of the thing, if you leave a bad address on there, it's easy, trivial to blow away the system here. One of the things is down here at the bottom, you'll see this always shows the stack in hex, and any result gets put in this res window, and the last line that's executed is always shown up here at the top. Just recently moved that. So now I'm going to go, and the basic types. This is the string valalock, and you can read about this. But okay, here are all the occurrences in the source file of valalock. So can get help on any phrase, and it'll return all occurrences. So actually, if I want to get it down to just where it's defined, throw the colon on there, and there's just its definition. And it'll bring in anything from a truly blank line to the next truly blank line. So that, anyway, one of the things is, let me show the other half of sort of the environment that counts. I use Slava Pestov, who I think is a great programmer. He did Factor, and I looked closely at Factor, but this was an early editor that he's got. And one thing that's very useful, and I use what that CS help function does. Let me come back over here. CS. By the way, this is one-eyed Jackie on my shoulder. It's pretty much my constant. Yeah, here's the whole definition of CS help. Essentially goes through this list, and it essentially just returns all the sections that are separated by an actual space. And I hope you can see here. One of the things I like about this editor, other than the fact it's got multiple views, I actually have about 8 views. There's the definition of the textual interface. But here, when it goes, it separates for CS help. It splits the text of all these things on totally blank lines. Notice this is a totally blank line here. But here, one of the things I like about this editor, Slava's editor, is that it's got an end, you see the end of line character. So this actually has a blank here. So if I ask for something like, what was that? That gets actually into the definitions of these meta things. If I ask for M store, it comes back with actually the whole vocabulary included across that. So anyway, that's the entire help system, and actually it's getting that stable that sort of defines getting it able to be used for something. I wanted to actually show this is, we haven't run into any time it runs into a search error in that search function, it'll go and put a diagnostic there. So, but that's something that people can. This is cozy. It's like Sam's stuff. There's tons of loose ends. But one of the things, and when Sam was talking earlier, where he made this comment, which he wants to have the ability to have open and understandable everything from the transistor up. Well, and this, cozy is very complimentary because it wants to take it from that naked X80, well, in this case, X86 fourth, but I did not want to use a fourth that was in, it had to be in some assembly language. What I wanted to do here, the help, basic instructions. These help instructions here, these are the native Viva Forth help things, and they output directly, so they have to be executed with Shift F6. I'm hitting Shift F6 now, and that gives you the basic Ron Aaron's basic. There were a number of other people involved. A guy named Danny Reinhardt over in Bremen actually interfaced the IUP interface that this is. He interfaced that vocabulary. So that's, and there's a guy named I got an old fourth friend named Helms. I'm not sure that was him. But C is the basic word to go and see the definition of any word. For instance, search. And I'm Shift F6 for these because that was output directly. But, that's my cover function, actually. Okay. The rest, if you download it, I could get, actually, one of the things that I should say, all of this, when I hit Shift F6, and this is very, very much, this is very much influenced by Arthur Whitney's K, which added a layer of transparency to the structure of APLs. One of the things is it just went to the structure that actually Bacchus described for arrays of just lists of lists. Well, I don't think, well, let me go and show. Yeah, actually everything here, I ran into limitations of where I am dealing with this whole Model T. Any of you that followed some of that Tesla overdose a couple of weeks ago, but everything is in a list, a dictionary is what was the terminology used in K, but D names actually for dictionary names. Those are the objects that are saved whenever you hit Control S, and the little tick mark here. This is the upper left-hand corner tick. Let me see. Let me grab one. For instance, text. Okay, since we're in text. And just Control C, and let me bring it down here. R. Okay, let me go ahead and access. text here to show fetch is fetch a variable from the memory, and I'm doing a Control S because you never know. But here's all the text. This is actually the same text that's down here. And notice the stack is 0. Sort of the statement is from stack being 0 to stack being 0. Let me just. Oh hell! Oh hell! I just made a major. I hit F5, which, if you look at the instructions, goes and I now have a copy of this. I've really messed up my notes because I just dumped this entire listing of text down into itself. Oh, let me see. I should be able to fix this up, actually. So, because it's not been stored yet, here I'm not going to do R text v fetch fetch. Oh, I don't know. Actually, I don't think I have a word to. Heck with that. I'll just work. I mean, I know this is messed up, but you know, somewhere above or below us is a totally redundant copy. I'm not going to try to go and fix that, because actually what the real reason is because the best way to find out whether I've got a word and am I thinking I don't. Text, C text, and Control or Shift F6. Oh, I guess I do. Okay. So let me go and replace the text that I'm in with the text that the last sword saved copy. Okay. Oh, and I don't want to go and do a save. So we may bomb. I think we bombed. We bombed. Okay. No biggie. Let me. I guess I got to go out here, and yeah. Okay. And back here, really bombed. Okay. Oh. Hell, I came back alive. So let's keep going. But in any case, yeah, let me really stop and get the questions. See if anybody.
I'll wander the room for questions. Anybody have any?
Whoa.
Silence.
Hey, Bob,
Any,
is that J edit?
what?
Was that editor J edit?
Yeah, J edit.
Okay, I didn't see it up there. I just wanted to make sure.
Yeah, no, it's I find it very convenient. You actually should want to know what the nature of what the nature of the reference counting and so forth is, because that in some ways the transition from a fixed address space to dynamic objects is one of the most fundamental sort of transitions in domain. And then the APL vocabulary just allows you to have almost a sense of geometry in thinking about your the nature of your data. I mean, that's the one thing it has over just objects in general. Everything is just a list. I guess I should have Am I still on screen shared? Yeah, let me go here and show that, because I never finished really going and showing the nature. R is, like everything else, a list. And an old APL word, row, gives its count, how many items there are. And there are 2 items in a row. There are 2 lists. And the first of them, well, I could go, and this gets APL-ish. Each M. Notice I have a tick on row, actually more general thing, just to have any arbitrary function. Hey, bird, you're going to have to go. Get out of here.
Oh, we want to see the bird eventually.
Yeah.
I do.
That's oh, I don't know. It's an awfully social bird. Whoops, I want to go and put a little brace around this. You can go because you can go and essentially make in there's now the concatenative programming notions. Guy named Joy is supposed to be the most paradigmatic thing, but really I think in many ways Forth is the essence. But in any case, going and making that a function, I'm going to do I can always recover my text later. Yeah, each of these, getting back here, R is a list of 2 lists, each of which is 25 items long, and the first of them, I'll go and do this in a practically. One of the things, by the way, since you notice this is very much a notebook, all of this work in going and developing this, which ends up being, all examples, is actually there in the uploaded copies of my own private environment. Here's my own stuff where I've got phone numbers and everything. But let me go back here. Enough on it. By the way, having a reference window, remembering one of my major uses is remembering all my bloody passwords and all of that. In any case, oh yeah, I was going to go. There are 2 things. 0, since this is executed in the naked Forth environment, that 0 gets stuck on a stack. And one sure way to blow away things is to leave a 0 on the stack and hit F6. That will do it. But if you go and throw an I on the end, this underscore I goes and converts that to a cozy 1-item vector of a 0, an integer vector. So I can do that. Yeah. One of the things that's bad is I just left. I didn't do anything with that, and it left the R on the top. Let me go and hit and throw a row on there. Yeah, that cleaned the stack down to 0 again. Okay, but what I wanted to do is grab the first item of that, and actually the best form it goes in, but okay, that actually is what dnames is. That's the first column of R, the first list in R is a list of symbols, and that's one of the few types. The symbol is essentially a string. Well, in general, names are strings with no blanks in them. But in any case, that first column of these 2, that first 25, is the list of the names of all the items. And then let me do 2. Actually, there may be, well, I'm going to just actually go and do the row on that. Oh. Because I think there may be an item in there that'll blow the thing right. Yeah, so there are 20. Yeah. Anyway, so what this does, vfetch just looks up the symbol here in that first list and returns the value associated with it. So here, for instance, are all the Model T engine specs that I sort of screen scraped and turned into a table like that. And once again, let me solicit for I guess this is a you know, spanning the from the hardware from the transistors up to again this level of notation. Anybody want to see me do anything APL-y?
Kevin had a comment here.
You had spoken about your Model T ignition simulator. Do you want to talk a bit about that?
Okay, again, yeah, let me go back to, in a sense, it's not so much I wanted to go and do some computations on it, and that was, what, a couple of weeks ago, on a Monday. So, actually, I think it was the 16th. Yeah, here are my notes from after that. And one of the things is I found this here. This is Control F9. This whole more on Model T spark timing. I found this table of RPM because I was wondering about the timing on the whole thing. And so essentially I just went and did a copy on this table, and I'll skip the first things to the point where I got it in the form of this. This is a string here. You can see S quote starts strings and then just quote ends them. And of course, all of these things are immediately dynamically. This is a dynamically allocated object. But let me. Here, yeah, here's a string. Here I went and VM here. There's a verb which very useful in APL. Goes and converts a vector to a matrix breaking on lines. So I execute that, and now, let me re-execute this, okay? Because that's the result of my last operation. Is saved always in a variable R0. So this will take that result. Now that split it into lines, then let's see. I think it's more reasonable to go and just see this is the sort of computation than to get into what I did, because I have to read what I did. I see that I defined a new word to do float let's see. I tried it out here. Made that work. Okay. Let me see what this did. I just got the, but T1, it defined T1. I can see here. And, that's that one. Who's this? Oh, okay, there. It converted the first line to floats. Okay, took this input and converted that to floats. And I'm going to not try to go any further than that because I ran into the fact that this brace notation, pure force, does not nest. So that was anyway. So what I can say is this is my computing environment, and one of the things is to go and make it so that, in a sense, I have forth and I have an APL level environment, you know, back constantly. Well, I guess that, you know, one of the things I saw in Jack War's presentation, what, a month or two ago, was that he had a 5110 sitting next to him, and that had APL in ROM. So this is that same notion of APL as a tool of thought, but bringing it so that anybody who's got, I mean, clearly the future of hardware to me is in this room. So.
I got a question.
Nope.
Hey, Bob, you said it was inspired by K. The APL was inspired by the K.
K.
Right.
K, which has an open version now named Kona, K-O-N-A, but also K's market. To give a bit of history, Arthur Whitney, about the same age as Ken Iverson's son, and actually his father and Ken Iverson were like at college in Alberta at the same time. But in any case, Iverson, after, you know, in his later years, he created J, along with a guy named Roger Huey. And Arthur was like the same age as Ken's sons and so forth, but Arthur was the most independent mind, is the most independent mind, I think. And Jay went very much off the deep end in mathematics, in mathematical notations. In K, what Arthur did is go more for the real, if you will, constancies in data processing, and just went to this very simple structure of lists, and this dictionary structure where the association between the name of a function and the function is just that, this table association. And that's recursive tables. So yeah, you can have dictionaries of dictionaries. I mean, one of the big changes I've made in the structure of things is that every object has a meta address too, which generally can be a dictionary. So you can have an entire dictionary of metadata connected with every object. To get back to the nature of K, it really, well, just pull up kx.com, and I don't need to say any more.
Yeah.
But one of the other things that Arthur influenced is going to having this all reference counted. And if anybody's interested, I could go and show the vocabulary of reference counting, but that in many ways is the most useful and fundamental and broad, you know, application thing that's in the whole vocabulary. Because I seem to have gotten a lot right, because you didn't see the thing blow up, you know, and doing a lot of these. As a matter of fact, one of the things is I've got a bunch of useful phrases around, like this R names and so forth. But down here, these are all functions for going, and if you go and do AF1, it turns on essentially the logging of every object created, and that'll continue until it gets to AF0. Like, for instance, oh, well, there's an example. I can execute that. I don't know what the line did, but in any case, it created some things, and yeah, it created those addresses, and the minus ones, it deleted them. It freed them. And one of the things that I was very impressed, Arthur never garbage collects, and it's not necessary. I just go to the whatever the operating system memory management at that point when anything gets freed. But Arthur just keeps a table of log2 length inventory of segments of address space segments, and so he just goes and returns a segment to the list of free segments and so forth, and never does any movement of anything and so forth. So that's and I guess actually Ron Ahrens has also gone to a reference counted thing in 8th, which is much more towards, it's built in C or something like that. So I'm not interested. I want to, get down there to the arrays in silicon. Sort of at one end have the arrays of data, and at the other end have the mapping into the gate array. So.
So Bob, I have an application I'm touring around with in my mind, and at the base it's 6 million objects, and then that's related to another 12 million, and those 12 are related to another 24 million, right? And so that base number can change depending on it's going to be in the millions, mostly. Okay, and so I know K has some very large numbers that it likes to play with.
Yeah.
Right, and so so knowing that, I don't know if you saw Sam's. Bob didn't see your presentation, right?
This morning, yeah, I think he was watching.
Bob, did you see Sam's presentation?
Yeah, this morning.
Yeah. Okay, so
I made a note.
Okay, good. Oh, so
the thing is, the philosophy is so parallel. It's just and hopefully there's an overlap. So I mean, one of the things I wanted to ask Sam is when is there going to be some sort of a little mini card with a RISC-V architecture, so you can take over whatever cell phone you buy, whatever smartphone you buy. So, and because then I want to have Fourth Cozy on it. I want to be able to do science level things like, I get into this because I'm. I really, most of my time, an awful lot of my time has been battling this absurdity that the source of carbon to the biosphere is evil. I mean, and I happen to get into this, some determined idiot, in K, the definition of a dot product is plus slash times, okay, and that will not only act on vectors of a billion, tera, it will act on billions of lists of pairs, billions of pairs of lists, billions of that will operate across the first axis, the leading axis of your list. You've got to have 2 lists, and that'll act across it. But that's the entire definition, and that is so profoundly more powerful I mean, again, you can do a dot product on a map of the entire sphere of the Earth with that dot products of spectra at each point, or at each of your voxels, whatever, you know, with just that notation. So that's the end. I mean, I've got, you know, the things I don't like about K notation, because it doesn't really allow infix well, but you know, I just want to give me the computation. I find the fourth syntax actually very seductive in a way, because it's so open. But in any case, I mean, you know, obviously there's an enormous amount of detail. But in terms of going and writing a function that goes and handles all the reference counting, and I think Sam was mentioning something, well, you know, going and incrementing a reference count is pretty easy. You just increment the count. But when you decrement the count on something, if it itself is a list, then you have to go and decrement the count on all of the objects that it has, you know, and so it's recursive. I mean, that's again the first and most fundamental thing that got me started. I had a friend that invited me. He had a spare room down at this APL conference in Naples, 2004, something like that. And in any case, I wasn't registered for the conferences, so I had nothing to do but sit around by the pool and see if I could go and make a recursive list and then store it to a flat file. Because in some ways, that's the really crucial thing. You have to be able to have a data structure that, let me go, where I gotta have a, yeah, here we go. Oh, this is not where I want. Just let me just go into fourth cozy. Just go and show you what you get. You download. This is essentially what is in the zip file. But yeah, I mean, cozy.csy. That is what contains R. You know, that's the thing that list of list structure has been converted to a flat file and back again, and with no redundancies. I mean, with, you know, again, it's sort of, if you will, reference counted in the flat list. So, I mean, I find it, you know, this is the piece of software I expect to live the rest of my life in one form or another. That's why it has to be, and I mean, you know, the fundamental. Fourth is fundamental.
Any other questions? Well, thank you, Bob, very much for speaking to us on this.
And stop by and download it, and, you know, I plan to actually hold hangouts and so forth to sort of get the only way something is complicated or as massive as this, because in a sense, I mean, when you consider all of the open code from all the x86 and Ron and rest put together, it's a brilliant piece around the world, all the way up through the APL. It's a cliff to get up and over. It's a mountain climbing. Okay.
So, Bob, if I might ask you to send me whatever links and notes you have for this talk, maybe if somebody's interested in this stuff, just enough to get them started. The reason I ask is that Dave edits the monthly meeting notes and posts them on the web, so that would be great if you provide that information. So we're going to take a short bathroom break.
Well,
and start up again in a few minutes.
Technology work, powerful.
switch it off from where I'm at and move back to my space before my talk. So I'm going to take you off the screen. You're welcome to stay in the Hangout,
For sure.
but whichever way you do it, I may mute you.
Last picture of Pikes Peak.
Well, go to the screen.
Oh, absolutely. I drive it every
So often. If I need to, it works very nicely.
One of the questions that I wanted to address, that I didn't want to address here, is
So I have one logistical question. Am I correct in assuming that in the past we have had issues with takedown stuff if there's content that's played that is likely to be recognized by YouTube?
Ting has been very good to warn us when that was going to happen.
Okay.
And we have not broadcast that.
Okay.
We've never been taken down.
Okay. The reason I say this is because in the about maybe the first 1/3 mark, I wanted to play one YouTube video. Is there some convenient way to sort of cut out and cut back in, or?
I don't know. Do I have a pause button?
Yeah, yes, a pause button, I guess, is what I was looking for.
All I can do is stop broadcast, which means I have to create another one.
Lord, that's a hassle.
Yeah, that's not the way to go.
Could we mute during that time?
We can certainly
We
mute.
could mute, and I'm assuming that the playback of the screen is not going to be sufficient to.
What we are we know that Google is not doing this manually.
Yes.
We know.
Yes.
Therefore, all we're worried about then is somebody viewing it and complaining, which is also unlikely.
There's also the automatic. There's some limited amount of automatic.
Well, they're doing correct. I'm assuming that my camera is not good enough
Yes.
for them to pick up much of anything to scrape it. So I'm not worried about that. It's the audio that they typically are scraping.
Right.
And they will pick it up very quickly.
So perhaps if we mute during that.
Right. We can always turn off the mic.
Okay. All right. Well, that sounds good.
Yeah. So cool.
Okay. So I'll flip. It's just my mic that's listening. So if I turn it off.
Correct. It's only who's listening? Who's broadcasting now? Seeing that we just broadcast that. Where's the mic? Here's the mic. That's why. We're being listened to at the moment. How about if I turn it?
You're on mic. Okay.
I can apologize for my ineptitude for bringing you on early.
Yes, well, I apologize for Kevin's ineptitude. Oh, right.
I think that goes without saying.
Indeed. Alrighty, so, fourth haiku for the impatient. You're all here to hear about how to make haikus. You know what the deal is. It's about beauty in simplicity. So you take something like this, small number of words, and boom, you've got a beautiful picture. And that's what's cool about this. You take something like this, and boom, you've got amazing pictures. You've got a tiny little program like this, and you get a wonderful picture like that. So you're like, give it to me now. Give it to me. Give it to me. Okay. So what are you going to need? You're going to need a browser. You're going to need Chrome or Firefox, maybe IE if you get the latest bleeding edge version, and the stars align. Okay. Yeah, well, you know, not the version of Internet Explorer on Kevin's machine. Okay. You need a good GPU. At least you do if you want to do animation. There is a JavaScript fallback. It'll sort of run. You know, you'll see it draw. So, but if you want things to move, you're going to need a good GPU. So I want you to all feel the zen. Let's go into it. Okay. So what are we going to do? We're going to learn how to control color. We're going to learn how to have some fun with fourth. We're going to grasp geometry. We're going to wiggle some waves, and we're going to taunt time. Okay, I hope to light a fire in all of you and get you excited and go out there and actually try to write a haiku. I want to see a haiku from each and every one of you. All right. Okay, so let's talk about color. Let's talk about color. So there are three primary colors, and this is where I'm going to temporarily cut out the sound so we don't get resume sound in our broadcast.
You may not want to put that in your pocket because it may.
Oh, let's not do that then. All right. All right. So there's the primary colors that we teach to school children, which are really the primary colors of pigment. And there's this, these are sort of the subtractive primaries, and there's a lot of elaborate issues here. But what we're really interested in for haiku for is the additive primaries, the primary colors of light. So to really do anything with haiku, fourth, you're going to have to be thinking in terms of the primary colors of light. So let's make sure that we're on the same page there. So here they are. Okay, so so I'm assuming you folks are all familiar with them. So red and green make what? Yellow. Okay. Green and blue make what? Cyan, indeed. And blue and red make what? Magenta. Okay, and if you take all three, red, green, and blue, you get? Black. Say again.
Black.
Whites. Whites. Additive. Indeed. Okay.
Well, it depends which way you're putting them together.
Indeed. Okay.
If I had gel, it depends on which way they're coming to you.
Indeed. All right.
I just had a revelation that it's fake.
Okay. So everything in Haiku Forth is the colors are on the stack, and so at the end of the day, the data stack is the place you are going to end up having color. So your Haiku is going to get run, and the expectation is at the end of the execution, one cycle of your Haiku, you're going to have a red, green, and blue value sitting on the data stack. That's the contract you have with Haiku Forth. Now, it's a wiggly contract because you can skip some of them. If you only leave 2 values on the stack, they're expected to be red and green. If you leave just 1, you get red. So there's that. And little known fact that actually is used by a very small fraction of the haikus, if you have a 4th value, it will be treated as alpha for transparency. We'll talk about that in a moment. So, if you have these values in the stack, let's review. What do you expect this would produce? What are we going to see? Red, indeed. Okay, and this one is green. Yay. Okay, and this one is blue. Okay. Next, tricky. What's this one? Yellow. Cool. Okay. What's this one going to do? Orange. It's right. Okay. And trick question. What's this one? Orange. Okay. You're on the same page. What about this one? Dark red. Yep, dark red. Okay. Okay, so we'll talk about words. Words. Okay. Lots of words in colorful. So first of all, word about floating point. So in Haiku Forth, things are built on top of JavaScript, and there's and then it gets converted to WebGL, at least if you have WebGL. So in JavaScript, all the numbers are double precision floats, whether you want them to be or not. So we mirror this in the WebGL backend for compatibility. So the consequence is embrace the floats. Okay. So in Haiku Forth, forget everything you know about the data stack being integers. Forget everything you know about the return stack being integers. It's floats. So there's good and bad to that. We'll see, but it opens up some possibilities, and at least it fits the machine model. So let's do it. All right, so there's lots of math operations that you have in Haiku Forth. You've got plus, you've got minus, you've got times, you've got divide, you've got mod, and you've got negate. You've got raised to a power. And you'll notice that I don't bother with putting an F in front of these operations because, again, everything is implicitly float. You've got the trig operations. You've got my personal favorite, arctan2. It's great because this is the operation that lets you do the inverse tangent of a ratio, and it avoids having discontinuities when you're dividing by 0. Yes? The return value of units is in radians. So, yeah. Okay, you've got log and exponent. You've got square root. You have got floor and ceiling. You've got absolute value, and because we've got all these trig functions, you've got pi because you're going to need it. Okay, now you can shuffle the stack in all kinds of the usual Forthy ways. You've got dupe, two dupe. You've got over. You've got drop. You've got swap. You've got rot. You've got minus rot. You don't have pick and roll, and there's a good reason you don't have pick and roll. This is going to get run on the GPU. It's going to matter whether you're reaching down and touching stuff. All this stuff has to get reduced to something that can be run efficiently, and having that is not going to make life happy. You have a return stack. It's not a real return stack. It's a pretend return stack. It gets reduced out before the program gets run, but you have it. I love Chuck's push pop and color forth, and so I couldn't resist them. So in Haiku Forth, you can use either form of the pushing and pulling for the return stack. So you have comparison operators. Shockingly, these are not as important in all their variety as they would be in an integer forth. You'll find you're using less than and greater than a lot and not much else. But you have equal, you have not equal, less than, greater than, less than equal, greater than equal. You have logical operators. Now, I made a bad choice here. I'm going to admit it straight up. I went with logical operators that are equivalent to the C operators. I did this because at the time it seemed JavaScripty. It seemed to fit. So these are not bitwise and or not. These are
these are logical. So you get a 1 or a 0 on the stack based on the result here. They are what they are. In fact, there's a bit of a debate with my online community as to whether I should change them. You have min and max. These are very useful. Okay, and then you have some words that are just they're there because when I first started doing haikus, I had no idea that I would be able to do so much with the haikus with so few words. And so I thought, you know, this is going to be really hard to do interesting things. So I added some words that are a little complicated. I added complex add and complex multiply because, you know, I thought, hey, now there are some really cool haikus out there that use these words. In fact, I'm going to show you some places where these can do some neat things. There's a random word. This one's stupid. I don't know why I did this one, actually. What happened is I thought, well, random noise, you want to add that. The trouble is I'm actually emulating this with a fixed form function, and so you could do it yourself. It's, you know, and noise is only so interesting. I thought noise would be, you know, something that 0 to 1, it's uniform. Pretend uniform, yeah. So that was a disappointing word. There's really very few places that it's useful. Let's talk about geometry. So we control the horizontal. We control the vertical. So they're x and y, right? And time itself will bend to our will. We control time. But we need to know the board. So this is how it works. You've got your x coordinate, you've got your y coordinate. This is the origin is in the corner, lower left-hand corner. It's mathy, right? So you go from 0 to 1 in x and in y. That's your haiku. That's how things are laid out. So what is happening is that for every pixel, the haiku is being drawn, is being evaluated per pixel. So as x varies across, over on the left-hand side, x is 0. Over on the right-hand side, x is 1. So what do you expect this will produce? Well, let's look at what it actually does. So we've got a gradient that goes from all black on this side to all red over here. If this had been a 1, right, you'd get all red, right? If this had been a 0, you get all black. Instead, you get a linear interpolation across. So what do you think that's going to do? Exactly. Same thing for green. So green is varying with x. Okay. What do you think that's going to do? Yep, exactly. Cool. Okay. Now, tricky. What's this one going to do?
Black gradient. The other way.
With white. Right? Because you've got the same for R, G, and B, so they go up. Cool. What about this?
A vertical gradient.
Yep.
Same as.
Yep. Exactly. Okay. Now, what about this? Now, I should mention one thing I forgot to say about the comparison operations. Again, they're C-like comparison operations. I'm sorry, this was a mistake, perhaps. It's. Yep. Bingo. So, all right. So that. See, you're seeing it. Okay. So remember this guy. Okay. Suppose that we wanted to flip it. How would we do that? Horizontally. Yep. Bingo. Cool. All right. All right. Let's talk tricks of the trade. Okay. Kazam. All right. All right. So we just flipped something by hand, but you know, and it works sort of like this, right? We can, for a particular coordinate, we can flip it, you know, along one of the axes, sort of like this. But you know, we can do it in line like that. But suppose that we wanted to do it in general. There's something really cool you can do because this is fourth. So you can do this. You can redefine x in terms of its previous definition. And so if you take this little beauty and you slap that in front of any haiku, what's going to happen is from that point on, x has been redefined. Now it's using the old definition of x at this point. So you stick that in front of any haiku, complex or simple. Yes? Yes. You'll flip.
But you will have your dictionary are going to start getting bigger and bigger.
This is true. Fortunately, in Haiku 4th, all of this gets compiled ahead and thrown away, so for what it's worth. So no, it's a fair point. So if you make this operation and you stick this guy in front, it flips, and that works whether it's just a simple gradient like this or it's an immensely complicated Pac-Man thing doing stuff you don't even understand, that I don't understand. All right, what do you think this one's going to do? Sam's got it. Only red. There's only one value on the data stack. Yeah, okay. He's got it. They got it. Do you think, Dennis, you got it? Yeah, I think.
Greater than will be red.
Uh-huh. So, here it is. Okay. Score. All right, so, let's say this. Now, here's the thing you're going to see a ton, and I will confess, with haikus, when I make them, I don't always know what I'm going to get out. And this is a medium for art, okay? So what you do is you make sure that the data stack balances out. You got those RGB values, and you play around with it. So we had x, y greater. Let's throw a square root in there and see what happens, because whatever was on, whatever y was, we'll just mess around with it. What does that give us? It gives us, that nice square root curve. Okay, and let's talk about waves, right? So, hey, let's stick a sine in there. Let's do the same thing. What do we get? We get a tiny little, see the little bit of a wiggle, but we're not seeing very much of it because we're only going from 0 to 1, right? So let's say we wanted to have more of it. Well, we're going to use that pi that we had in there. So we're going to multiply y times pi before we apply sine to it. And then we can, and then we can see the bump. All right. Well, why settle for 2 and we can do 7? Let's grab a whole bunch. Okay, but wait a minute now. They're clipped off. Why are they clipped off? Yep, you're right. Sine goes from -1 to 1. So what we want to do, we want to shift that over so we can see it. So we want to add 1, and then we're going to go from 0 to 2, and then we'll divide by 2 so it fits in our screen. So we'll stick that in there, plus 1 divided by 2. And then we can see all our bumps. Okay, now, actually back up. So now take a look at this beauty. We got this interesting picture here, fairly small number of words, and everything from here on over is just a function that takes 2 values. Well, if we put 2 different values on there, we might get something interesting. So let's say we flip x and y. What's going to happen? Yep, it'll be, we flip x and y, it'll be flipped like that. Okay, so what if we make that, we give that a name. We'll call it Q, all right? So we'll call this thing, everything in front Q, and then we can do it twice. We can do XYQ, and we can do YXQ. What's that going to do? Yep, he's got it, okay. We're going to see them overlap like that. Okay, so boom, tricks of the trade, all right. So, all right, so we did this, and this is cool, but now, if you think about the haikus you've seen that you like, this is like a hard edge. Now, how often do you want a hard edge? You want a soft edge, right? So here's something really cool. One little trick you can do. Change that greater than to a minus sign. And look how smooth that gets. And there's a neat visual correspondence here where you can soften the blow. So if you change greater thans to minus signs, it gets smooth. If you change less thans to swap minus, it gets smooth. If you've got an anding of 2 regions and you change it to a multiply, you get a smoothened combination instead of a hard union. Same thing with OR. And there is a correspondence between mod and sine or cosine, but the trick is that it depends a little on a scaling factor, right? Mod is based on the range you give it. Sine, you're going to have to throw an extra pi in there, and you're going to have to clip the range on the other end. Yes, Sam.
It's funny that you mentioned alternative complications, because when I was writing equilibrium, I was looking at fuzzy logic, and they were talking about alternatives for and greater than. Now they use things like min and they were actually able to find all the Boolean operators in terms of min and max only.
Oh, interesting. I have not explored that.
Actually able to make a fuzzy pattern.
Ooh.
Interesting, but
Mhm.
but yeah, it's kind of neat that that bring up this alternative.
Yeah. And definitely, I mean, this is one of these areas where anytime that you've got, either a harder or a softer edge than you want, experiment with the operator, and you may find that you get something that's the same but, different in a way that's useful. Because again, this is art after all. It's an interactive process where you're seeing if the image that you like is what you want. So what's this going to look like? So if it was just this, if it was just x, right, we get the gradient going across. Add in y, we got the green going up and the red going over, right? So we get this. So yellow in the corner, red, green. Okay. Now, what's that going to do? Yep. So it's going. Yep. So it's going to repeat it 5 times, right? So you get the Venetian blind effect, right? So, cool. All right. Now, boom. Tricks of the trade. All right. So you can never have too much of a good thing. All right. So the key thing that I do when I make my haikus, at least my weirdo dithery ones, is I find an interesting transform. I give it a name because things need names, and I use it over and over again. I use it in crazy places. Let's see how that works. Okay, we had this guy, remember? And let's say we did that. Now this is what I throw this one, like if you look at my haikus, I bet you I use this sequence more than any other because when I first added that complex multiply, this is the kind of thing I was thinking of. So what's this operation do? Does anybody have a guess? So this is so you do a 2-dupe, and then this is a complex multiply. This is a complex square, right? Okay. So so you got 2 values in the stack. You get two values back out, right? So it's not particularly intuitive, but it's different, right? It's not that same gradient. The yellow kind of shifted over here. So let's give that a name. Let's call it WW because why not? Okay. And then let's do it twice, right? We get that. We do it 3 times. We get that. We do it 4 times, we get that. We do it 5 times, we get that. Okay, so, and the same thing works if you got, if you get a more interesting operator, do the same thing. Apply it several times and amplify the effect. Okay, now, this haiku is in red and green. We're missing that blue. Another thing you'll see in all my haikus, at least all the ones that are just sort of one-off things, is, okay, I got this haiku, great, I need something for the blue channel. Well, just add a gradient. Add some gradient. I typically will take x and y and multiply them, and then you get some blue. And nice little blue highlight in the corner, and take something that was very flat, and now it's got shape to it. Now, remember I said we could throw things in weird places. We can redefine y in terms of this crazy WW operator, and then it does all kinds of crazy warping because you've warped the coordinate space. And so now you've got this weird shape that you would never have guessed you'd get. Yeah. And we can apply the same thing here. Remember, again, here, this is that one we had before where we softened it. But let's spice it up. In fact, we didn't do enough of the Q operator. We needed another time. In fact, let's take x and y, and we'll begin. And let's get the blue one in there, right? We'll have x and y plus and x and y minus, and get a slice there. Okay, and then, let's talk about transparency there first. Okay, so any guess what this will do? Dupe star, that's a square, right? So you get x squared, y squared plus, so you get x squared plus y squared, and then you're checking to see if you're greater than 0.5. Yep, he's drawn it with his hand. It's a circle, right? Okay, you at least the portion of a circle. Okay, so that's cool. But again, we want to soften it. So let's trade in that greater than for a minus sign. What's that going to look like? Same. It'll be smooth, right? Exactly. Cool. So we get that nice smooth gradient. You'll notice actually in the corner, and if you can see, shows up better on my screen there. But everything gets clipped out at 1. So once you get to that maximum brightness level, it doesn't matter if you go up above 1, it'll be treated like a 1. Okay, so now, we know this guy. He's cool, but like, what if we apply mask to him? Let's put that value we just figured out, this guy, as the alpha channel. And then it cuts him off, and you got a transparent shape. And I use this all over the place. If I want an icon that looks just novel and different, I'll make a haiku. I'll put some kind of mask around it to clip it off in a circle or in some other shape, and then I've got my weird, cool icon. You know. So if you ever need a transparent, icon or something, this is the place to get it. Remember this guy? He was all cool. Let's stick that same shape in there. Okay, wait a minute now. What happened here? That doesn't look like the shape we put in. What happened? Remember, we had a transform here. We warped space ahead of time. So suppose that we actually did want that shape. What would we do? Well, one way we could fix this is we could use the return stack. We could take that thing, that shape, and do it before we redefined y, push it onto the return stack, and then when we're all done, pop it off, and then we get the gradient we expected. All right, let's talk about time. Okay, so time in Haiku Forth is the way you get animation. It was a very, when I first conceived of doing animation, I realized very quickly it's like all you need is time, and that gives you the animation. The problem was actually all the effort to get there because there's no way the JavaScript up with the rate of drawing, but fortunately WebGL can. So time, it's just that t value in Haiku Forth, it's in seconds. And it's seconds since 12 a.m., and there's a very simple reason. I wanted to be able to make a clock face. And lo and behold, many haikus out there are actually clock faces of various sorts, including, including this clock here. All right, so, but here, let me tell you a secret about how I think about time with the haikus. It's just one more weird thing I can stick in there. So I can take an expression like t sign plus, where I've got a sign value that just oscillates every, it's on the order of pi seconds. And I add that at random places as an extra, transform, or I multiply by it at random places, or I scale it if I want a different frequency, and then add it in or multiply it in. So, why am I stuck here? Holy. Oh, and there. All right. So now we're going to go to demo time. So again, I want to see you all make a haiku. I want you to go to forthsalon.appspot.com and try it. But we're going to show you stuff with time, so we've got to do it actually on the website because I can't show it where I'm at. So let's take a look at how to do two things actually that are really important here. So you don't have to start from scratch. There's a huge library of stuff that people have made, and you don't even have to understand these people's programs to do stuff with them. You can just make a change and see what happens. So, for example, let's say we took, this is one I made a long time ago. And let me zoom in here. Let me make this full screen. Oops. All right, so let's see this here. Create a derived work. That's your chance to mess with other people's stuff. So you grab this thing out, and you get a copy of the program, and by default it puts in streak redux, and we're going to say it's streaked awesomer, okay? And we're going to say, I'm the author here, and okay, I did this weird program. I don't know anything about this program, but that's okay because remember I mentioned with time, all I got to do is let's just go in here somewhere like this y value here. Let's just take t sign times. We'll just multiply it by the sign of t and see what happens. And stuff happens, right? A lot of stuff happens, right? From just that one little change. And you can do that with any of these haikus and see how they change in time. And you can throw it in here in other places. Like let's say let's do t sign plus over on this one, and it changes how it moves. All right, now I'm going to show you, and then when we're all ready to go, we just say publish, and then your haiku gets published, and it's in the recent haikus, and there it goes. All right, now I'm going to show you. And I would encourage you to go and do that with a bunch of these. I mean, you can just go, here's Disco. Let's go look at, Disco is an easy program. it's bouncing around with these dots. Let's create a drive work. Remember we talked about doing those transforms up front. Let's take, we redefine x in terms of, x and y times together times t, and, we'll take the sine of that. And let's see what it does. Whoa, crazy stuff, right? You get amazing stuff just by twiddling around with what you got in the stack, and you play with it, and you see, and you have some instinct as to what's going to happen because of you're changing an x value, you're changing a y value. But at the end of the day, you try it out and you see. Okay, I want to show you. So actually, this is zoomed in. I'm going to pop up. So this is normal size. So I'm going to show you some secret features that you have to read the source code to see. Now, this is mainly because I'm too lazy to put it in the UI. But here's the thing. Look at this arrow up here, right, for some random haiku. In fact, let's actually go back to the original unedited one, right? We'll go look at this guy. And there's this arrow on top. So say you don't like that haiku. That's too small. So you can add a question mark, and you can say size equals, let's say 500. And you get a bigger haiku. All right, so you can change the size that it renders at using that. If you want to force it to use the GPU, you can do GPU equals in there. Another really cool one, I used this for that movie I produced a while back. So remember I told you, okay, the coordinates go from 0 to 1 in x and y? That's the default. You can do that, but you can also put in an arbitrary width and height. So let's say I made this thing 1024, so I'll say width equals 1024 and height equals 768, and now I've got one at a different, that one's too big for this tiny little screen, but now I've got one at a different ratio. What it's doing is it knows you want the center of the haiku to be here, so it's doing the 0 to 1 region here, and then it's letting you see off the sides of the haiku, which may or may not be what you want, but now you know how to do it. This is just in the URL. So if you want to change it, right now you have to change it in the URL. Okay, so
Is this written down anywhere?
hell no. So I will add a slide for it. I will actually add some docs for it just to be a good sport. But, okay.
When you're already doing that, could you set data link to your slide?
I will do that.
Oh, you're totally great. Thank
So
you.
suppose I have a different height there,
Uh-huh.
and I tell it to
It does not record the height with the height. And the assumption here, so the height, the 0 to 1, the square haiku, that's a standard, and I'm trying to keep that standard. This was mainly there because for a movie, you got more stuff, so I wanted to see what it looked like. Long term, maybe it would make sense to store it. I'm loath to add too many parameters, because one of the nice things about these haikus is how scale independent they are, how, they're not really tied to all this extra stuff you need. So I consider that kind of a backdoor. Cool. Are there any questions? How did I do on time?
Oh, yes. I remember last time you were able to have sound.
There is an API for sound, and it's a little bit complicated. Basically, what goes on, so there were actually 2 rounds of sound. I threw the first one away. The first round, what I did was I actually looked at, I forget which side it was, but I actually took a raw sample for waveform audio from one of the sides. That was a pain. It was hard to do, even it was a mammoth effort to get telephone sounds. The next round, at a number of folks' here's suggestion, actually, I introduced something where there are these 2 control points that emit sort of a flute with a pentatonic scale. And so I actually don't remember off the top of my head, but there's magic dot here and here. One of them controls the pitch, and the other one controls the volume level. And so the brightness level of the haiku, slides you up and down the frequency scale, and up and down in terms of how loud it is. But it's a pentatonic scale, so it avoids instead of stopping at every frequency, it slows between each pentatonic point. Yes, those are fixed points. Yeah, no, I actually think that might be the right direction to go. One possibility is I could have added more elements on the data stack, the 5th and 6th element or something,
would do this. And I actually have wondered if that might be the right direction to go. Part of why I originally went with that is I was, again, loath to sort of expand the scope of what wasn't built into the language, but in a way that forces you into a bad place, because you may have some really great visual, and what the sound that goes with it has no correlation to what's going on at those two weird points. Mm-hmm.
Frequency and amplitude, and maybe you might try phase. I don't know.
Yeah. No. There's.
Sounds like two more variables.
Yeah, maybe just two more return variables. One of the other issues that I ran into is that the performance characteristics of what you want to get out of the animation are different than what you want to get out of the sound. Especially part of why I did the corners is that the originally I was playing with raw audio, and there you needed to have a fairly high sampling rate. And anyways, but yeah, so it's definitely, I think on further reflection, the return stack might be the data stack might be the place for it. But yeah, and I think at the time I wasn't so sure that, I'm still not sure the pentatonic scale, it certainly solves the original problem, which is with raw audio, it was so easy to make horrible sounds. The trouble is now everything sounds like the same, basically.
You have to think about that, because using 2R and from R,
Mm-hmm.
it won't be the top of the return stack that you're interested in.
Mm-hmm.
The variables, it would be like local variables would have to be at the bottom of the return stack.
Yeah.
I mean, there's lots of things.
No, sorry, I could just put it on the data stack as the fifth and sixth element would be the other option.
Yeah.
So then there's no sound if you don't, but the other issue with that is then you're being obligated to have an alpha value, whether you want to. Yeah, so, right. But again, it's, as you recall, my original goal was keep the program small, so that's like, one more obligatory word just to fill in the alpha, and yeah. Anyways, it's a good point, and I definitely should revisit sound. And I think the other piece of information about sound I've gotten since having last played with it is it turns out that there are actually a number of folks that have done very small C programs that just emit raw waveform. It sounds pretty good. And so it turns out that while I had a terrible time with raw audio, I was just using the wrong kinds of expressions. And if you use the right class of expressions, it actually is possible to get a very small expression that actually does very interesting things in terms of oscillations and where the sort of waveforms line up cyclically and all that. And then we've lost the feed, but anyways. Cool, but yeah, no, definitely one of these days I should revisit sound. Sound is definitely an area that I don't feel has the level of completeness I would have hoped for. Okay, there it goes. Anyways, cool. More questions? How was that in terms of informativeness? Yeah? All right. Okay, awesome. Thank you all. I want to see those haikus, everybody.
I'm going to send a link to the list, and presumably it'll be in the meeting notes of the international signal flags used by ships, the alphabet of signal flags, and I'd like you to consider implementing as many of them as you can, or maybe just one. Pick one and make a haiku of it. So that's the signal flag haiku challenge. And if you're really clever, maybe you could translate keystrokes to signal flags. On a ship coming into port, there will be 3 flags, and that's their radio call sign. And it's usually the same for a given ship. It's the same call sign going into any port in the world. And the other flag that will be flown is the harbor pilot flag. It's the letter H, the alphabet letter H, and that means that the harbor pilot is aboard. And if you if you see that guy pass the entrance buoy and he isn't flying the harbor flag and he's a big ship, you got problems. He's in the wrong place and he doesn't know where the heck he's going. It's kind of interesting. In some ports of the world, when you're pulling into port and you have a relatively modern ship with bow thrusters and you can get into dock by yourself, in some ports of the world you're required to have, of course, the harbor pilot, but also tugboats to push you into the dock, because I guess the tugboat drivers and crew are all in the union and they've got some kind of deal where it's a rule. And there's no sense in it, because you can generally maneuver your ship better on your thrusters than you can with a tug, but it just goes to show you.
They probably did it when they were seconds.
And they may not be the tugboat union, the Association of Tugboat Owners.
There you go.
But on Smithsonian, they talk about the big ships. And they had a bunch of the cruise, cruise line ships, and with their bow thrusters, and only in a few places do they ever need the tug.
And those places are generally places where there's a rule.
No. He showed where they were going. It was a really tricky turnaround that needed to be done, and some of the currents were a little too radical, so they had to call the tug in. Because the guy deliberately said, I'm not going to call the tug in unless I really have to.
Yeah.
Now, other ships, I don't know, but those big cruise guys.
Yeah, and the crews can maintain station, maintain position
Well, generally,
very well.
generally, if it's a big modern ship, it's run by a big modern line, like, for example, Disney, and they've got enough money to go up to the folks that run the port, if they haven't built the port themselves, and say, oh, here are the rules we're going to use for our ships. So they get to decide. So it's all evolving. It's a function of, I guess, who has money and influence.
We're gonna have our terminal over there in Frank Mann, that's
All right, on that cheerful note, let's take a short bathroom break and get on to the next deal.
Now we have voice. And I think I have voice. I have voice. So I'm on. I'll start right away. Last time we met, I was doing Fitbit. Fitbit has ended. Now, in the last week, I was unemployed, interviewing like crazy. Somehow, firmware engineers are highly in demand right now. And yesterday, I got verbal offers from these guys. They're cool. If you have a Sleep Number bed, these are the guys doing the monitor. That's one.
The latest generation.
The latest generation of Sleep Number bed. They just started doing that this last year. And this is the other guys that also gave me an offer. Don't do that. Go back to the top. Yeah, they make embedded computers. And yesterday, 1 in the morning, 1 in the afternoon, I got verbal offers. So come Monday, I should be employed.
These guys are like the Cadillac of mil-spec.
Yes.
Embedded.
Yeah.
Brick computers.
Yeah. Yeah. They're up in Fremont. Over in Fremont. Newark.
Oh, farther up.
Right on that peninsula of Newark.
Don't be ridiculous. That's in New Jersey.
Right. So anyways, that was just interesting. So I threw that out. What we're really talking about here, though, is this guy. And the little device that's floating around, that's already floated around. And I should get onto the screen a little bit. You'll notice that on one end, in fact, I should show that on the screen. There's what we've been passing around. OBD. Oh. Well, you notice on one end is the connector. You will find this within arm reach of the driver's seat. So, typically under the dash, but most importantly within driver reach. Driver seat reach. Usually you take your left hand, put it under the dash, and you will find it. It's right there. And it's open. If you're doing that with your car, fine. On the other side of this thing is this little round hole that I just noticed is completely empty. That used to be the wire. These used to come out with a wire of a serial interface and eventually a USB interface. And now they pulled the wire out. It's a Bluetooth interface. And yes, this one in particular is a Bluetooth. I've also seen them only that big. Oh, yeah, and most of this is air. Most of this is air these days. Well, you got to remember that you're dealing with mechanics who are not the most graceful beings on the planet. Their hands are greasy. You're talking about a very dirty environment. I think I've told some stories about because I used to work in this industry. I used to make automotive test equipment. This is the reason I don't anymore. OBD is the reason that I don't. That was the OBD came a little bit after I got out, but when they started putting computers into the car, no longer did they need a separate computer to diagnose the car.
Other than plug into the computer that was in the car.
Yeah. But they became small like this. They became your smartphone nowadays. So making that diagnostic computer became very much passé, and I still know the company that owns all that stuff and my patent and all that stuff. But that's what OBD is. That's the connector that you've got underneath there. You hook it up with Bluetooth on your smartphone. Mine comes up like that with a password of 1234.
That's so secure. Well, it's printed on the case.
Is it?
Yeah, it is.
What was it printed on the case?
Yeah.
Oh, by gum it is. I didn't even look. I had to guess. And you have this fancy little app. And all of the advertisements for this program this app called Torque show something very, very boring. In fact, I may have that here someplace. There. Yes, they show something like that. Very boring. This is what I first saw with the app. Not real sexy. These days, you have dial upon dial upon dial, and you can spread them out, and you have 7 different pages you can put them on, and you can make it real pretty. You can make it real sexy. This is your new dashboard. Yeah, this is cute. And the cost at this point in time, I can't even remember. And there's many of them available. They're now out of China. They're a dime a dozen. Because they're just stamping them out. There's nothing to them anymore. It is basic. This is all very much let's see, there, that guy, that one. There's a page about it, and a link for technical library. The technical library on this page is how do you diagnose a car. Has nothing to do with OBD, which is weird.
How to diagnose a car, not how to read the code?
No. No. Not how to read the code. In fact, OBD has basically 2 modes. Let's go back over there to that guy. There are 2 modes to what you're going to do with OBD. One is gauges. All the analog signals coming that your car is using and generating are in some way coming out an OBD signal of some kind. And then there are fault codes, where your car thinks, turn on the check engine light. If you've ever had a check engine light, there's a code behind it that says what's wrong. And this is the way you can clear them. And that's the reason that I got this thing, is my Jeep occasionally gets code and turns on the check engine light.
There's on Amazon, there's one for $12 and one that looks a lot like yours for $24.
Yeah, that's about right. It's about 20 some bucks. But those are the 2 things you're going to do. You're going to be able to display your codes and clear your codes, which you normally have to go to a mechanic for, and display your gauges.
in the car started hearing that this could plug into?
The computers predated the connector.
True.
Um,
1985, I don't have a connector.
Well, the first diagnostic connector was a honking big thing that Volkswagen had. That was in the 60s, late 60s.
Yes, they started putting computers in before I left the business and joined Fourth Inc., and that was in '88. Right, so you don't have the standard OBD connector. Every manufacturing was doing their own thing if they even had a computer in the car. If you've got an electronic engine, you have some, or electronic ignition, you have some form of computer. Right. Correct. Yes. Yes. Yeah. And no, they are mostly these days power PCs. Or they started out 68Ks, and now they're mostly power PCs. You've got the noise immunity. You have a huge noise problem. It's huge. Yes. The amount of caps they have to put on your radio so it functions is huge. Yes. So anyways, you've got the two functions that you're going to be doing mostly these days. Where am I? Here. That guy. This is the company behind the app. And they are doing some very fancy stuff. Like, you can get those graphs, which are a web interface now. They've tied this into a web interface that you can get long-term measurements. And that's what race car drivers want. This is for, it used to be, around the time they started throwing computers in, the aftermarket was a new PROM. You have a new ROM that you put onto your computer to make it do fancy stuff. Now you tune with an app. And that's what you're doing. Now, to get any of this information, though, and I did try to go look for the specs of this let me see, where was I? I think over to this guy. To get at some of the...
Now the Tesla has all this type of diagnostic.
Still correct, because there's some analog stuff still there. Not much. Not much. But you still have a lot of battery measurements you've got to deal with. And so they still have, I think they still have an OBD connector. Yeah.
They also track your actual app that you follow. So like that guy who Tesla.
Right. They caught him.
Really bad mouth Tesla because it's like, oh, they claimed this battery life, but I only got blah blah blah. That's when Tesla came out and said, oh, by the way, our wireless uplink says that you actually drove all over the place.
Yeah.
Which actually exceeds our stated battery life. So
yeah.
They nailed it.
Yeah.
Yeah, they track all the performance data on it. It's almost like a wireless ODB, see their uplink. So they get all the stats from the units.
Yeah, they do it over software.
Oh, that's not a good link. All of the information now. That's a typical one. In fact, this is a cheap reference. At $72, I saw one for all the SAE protocols, all the SAE documentation,
is 500 and some bucks for the book. So they want money for the books now. This is like the IEEE wanting money. It's the same type of thing. So I don't have the spec.
It's even better than that. There are some codes for high-end sports cars that are not documented and are the proprietary property of the car manufacturers. So you buy a high-end Nissan, they won't tell you what the code's.
Yes.
Really? So basically, they're kind of like, manufacturer separated code.
Yeah.
So every car manufacturer has
Right.
their own like header.
You can see on there it
If
says GM code.
you have, well, specifically, and this is one thing that I did very early on as diagnosing car, is you have to have a cycle that you are repeating so that the software can figure out where to take measurements and do its work. You've got to sync a process with the software. That's what this driving cycle is. Each of them have a different driving cycle that you have to go do this process, and the process is basically that. Cold start, idle, accelerate, steady speed, decelerate, accelerate, steady speed, decelerate. And now they can diagnose a car. But that's what you've got to do. And it's manual because you don't want the computer doing this. Although that's coming, I guess. That's what I mean. In Google cars, I'll bet they do this. Go run it through this cycle. And, okay, you'll notice that we're talking about OBD2. There was an OBD1. Didn't last long. OBD2 is fairly useful. OBD3 now will keep track of position and everything that the police want to know. And they're having trouble getting it accepted. Funny thing. It depends. As consumers, we give away a lot of information. Some of us do. And one of the big thing that trips most people hackles that they don't want to give away is position. They don't understand that their smartphone is already giving away position that they didn't even give permission to give away, but is happening. But it's specific in OBD3 that information is there.
Isn't that, you have to go through that driving cycle before you can actually say that I've gotten rid of the trouble code.
The reason for this cycle is for the mechanic, after he has made a repair, or if he is diagnosing a symptom or something, he'll go through this to begin with, find out what the codes are, then after he fixes something, he'll go this again to know that it is corrected. But that's what that's for. So that's OBD. Kevin made the suggestion, is there any place for fourth? And I don't know of any anymore because it's all a web interface. Does fourth do web interfaces? Can. Yes, it's more trouble than it's worth. You're going to have to spend some money to get the protocol. Are you going to break into the Bluetooth interface? I don't know if that spec is published. Yes. Now, you will notice also that there are many connectors, many pins here. And I can't find right now where
Well, there's a CAN bus hardware layer.
there,
That's pretty well documented.
a couple of the pins on here is CAN. CAN is on there, plus a few other proprietary protocols. Not all cars have this number of pins in their connector, their mating connector. They only have some of them. You don't need them all. So you have probably 5 different protocols that you've got to know about to be able to do this. Probably not. There's no way GM is going to do the same thing as Ford. They're just not going to do it. Nowadays, this is not European. European does some of this. Europe complies with US when they have to. If they want to sell a car in the US, they have to have this. Therefore, they do some of this. But if the car is never going to come onto the US soil, it doesn't have any of this. They have their own proprietary stuff. There's a lot of proprietary still in the world. So are they going to do the same thing? No. This is what your car is doing. If you gray market it in. If it goes through customs, it will have this.
But it may have just enough to be
Correct. Yes.
having enough pins to do something.
One of the protocols or whatever, and they may use other pins in other ways. It's
So these aren't universal.
for U.S. cars, yeah. Every car sold in the United States has one of these today. Whether you can get a mechanic to accomplish any change on your car is the question now. It's a mechanic today is just part swapper. They don't fix much. They swap parts.
Right, exactly. Well, I had some error codes pop up because my fuel pump died, so I had to get that changed out. But then there's 2 tripped error codes in there, which of course flipped on the
Check engine light. Yes. Be glad that it didn't go into limp in mode. Limp in mode will get you to the mechanic. That's it.
There was no gas, so it wasn't taking me in there.
Right.
But they were able to clear the codes that were in there.
Yes. And that's why I got this, to clear the codes on my Jeep. And I have a stuck throttle position sensor. Whoopee. Not something to get fixed. Go clear the code and it'll come back again someday. Whoopee. But that's typical. That's what OBD is. I don't think there's a good place for fourth in there. There's too big of a stack. The software stack is huge. So, yes?
The thing that I'm seeing is in aftermarket performance cars.
Correct.
Especially not market sports car performance car like the Hellcat, 700 horsepower unit, 500 horsepower unit. So it knows through linking and going into the local computers what's going on.
Yes.
But there's a lot of aftermarket stuff for professional racing, as well as I'm looking at for taking well, I have a 2002 GMC engine. I have a guy trip real quick on the computer so I can get it running.
Yes.
Because I'm putting it in another car. But time, I'd say, well, why did I pay him $100 just so he could get rid of a few codes and show me how to get this thing running?
Mm-hmm.
When I want to actually do performance tuning.
Right.
And that's where you go in, and like on my motorcycle, I've got a Power Commander 3 on there, where I go ahead and actually do the air conditioner ratio and all that stuff. So that's where I think fourth would be ahead. We have a compact code that allows aftermarket guys to do performance-oriented things.
What I don't know, and I wasn't able to really find out without the spec, is I know there's a ton of output from your car, but how much input it takes, I don't know.
No, I know, that's the secret part. That's where I'm hoping
Yeah.
something the tool that the fourth guys would do, but get in there and just start teaching them out how the assembly goes.
There you are better off pulling the ROM, getting into the ROM, and disassembling the ROMs. And most of the high performance doesn't, this is just a monitoring tool, as far as I know. Mostly you're going to have to pull the ROM, and there are still ROMs available for performance. And you'll tweak the ROMs, and they'll trick them, or they'll tweak them for you. It's because this was homegrown in the U.S., customs couldn't stop it like they did with the satellite broadcast dish. That customs stopped. This customs couldn't stop. They could not shut down the aftermarket. The U.S. could not control this because mechanics are very, very sharp, even though they have fat fingers. Most of them are very, very sharp. Or the old school mechanics are. Old school mechanics, I love them. Worked around many of them. They know how to make the thing work. Now, most of them are frustrated now that all they are is part swappers. But, so, okay?
That's only if you're not rebuilding something for sports enhancement or classic cars. That takes still
Correct.
skill versus being a
Correct.
mechanic in today's part swapping.
And I'm not sure what to call those guys. They're still car mechanics, they're auto mechanics, but they know how to actually work with an engine. And it's what I've learned.
I would just call them classic.
They're classic auto mechanics. The guys that can take a screwdriver and put their ear to it next to an engine and tell you what's wrong. And I learned how to do that. I can still feel an engine and know if it's misfiring. Yeah.
My background in instrumentation, one of the interesting things that I remember, I worked at Tektronix. We were selling Morty and Schwartz testing equipment here. Like the best time was 2000. What I stumbled across was a piece of equipment. I think it was a telecom test set for telecommunications, right and forth. Inside.
Yes.
And I said, well, what about handheld devices with four of them that do lots of diagnostic testing or tweaking, lots of stuff going on. Like one of the things I would like to do is actually monitor air pressure in the manifold, non-turbocharged, as well as exhaust. Look at the mechanical vibrations, the pulse fluctuations.
That would be interesting today.
Diagnosis that way.
Right.
One of the things I heard really interesting the other day, I was watching a program on math and music. The guy says, the ear does the FFT.
Yes, it does. It does.
I know I can discern discrete frequencies. So the ear's doing the FFT, because I was wanting to do FFT on the intake manifold pressure so I could listen to what's going on. For the asthmatic breathing, just like a doctor would listen for a funny heart. I want the mechanic to do it. Get a display and begin to let him normalize things out. Look what normal is, look what abnormal is.
Yeah.
Time sequence it for different cylinders and say, that cylinder's not doing right.
Correct.
Not acting like the others.
I'm not sure I would do it with air pressure because that's Secondary, do it with an accelerometer. Do direct force.
Of the air moving in?
No, not the air, the engine.
He's talking about directly
I'm
sensing
talking
vibration.
about the actual, looking at the fluctuation per cylinder.
Correct, on a standard carburetor, not a fuel injection. On a fuel injection? That's true on each one.
Sit there and listen to each one.
Yeah,
And begin to make comparisons.
yeah,
And
yeah.
you synchronize them with the firing order. You'll say when the intake valve begins to open, that's when I want to start using the air pressure.
Oh, yeah.
And the air pressure sensor will be very sensitive and very fast.
Correct. And you can then look for turbulence.
No, I'm not looking at turbulence. I'm looking at actual breathing ability. It was similar to what Volkswagen did
Yeah.
80 years ago. But they wound up checking cylinder pressure by monitoring starter motor current.
Yes.
What they said
Yes.
was that
Yes.
they monitor the current correctly through a real small resistor,
Yeah.
200 amps of current going through the starter motor. You'll see fluctuations. And if the cylinder's not got the same compression, it'll
Yes.
have a weaker amplitude.
Yes.
They
Yes.
said, that's a problem.
Yes.
So you go, it's that subtle stuff that I'm looking for. Same thing with exhaust. Intake is breathing in, exhaust, I want to hear, is it coming out the same?
Is the pattern the same?
There's
Yes.
lots of patterns that can be looked at.
Yes. Absolutely.
Again, compact test equipment, or you might say engineering tools to do engine, not so much diagnosis as engine development.
Engine development is where they're still looking at all of those measurements. In consumer, they're not. Yeah. For the aftermarket guy, and race cars and any performance engine, they're looking at all of those measurements now. Yes. Yeah.
But a lot of them don't understand electronics.
Yeah.
I
Yeah.
talked to some NASCAR guys, I got some weird things I've been doing. And the only guys that understood me were the guys who had an electrical background and a mechanical background. Like, oh, I got it. The mechanical guys,
Yeah.
electrical guys, are you sure they can apply? And that was the same.
Yes. And that's why one of the things I appreciate about a mechanic, the old style mechanic, is he had to know both. He had to know both the electrical and the mechanical and the physics into it all.
I guess I don't deal with many of the mechanics that you're speaking of, because most of the guys I know are sharp. They're
Yes.
much more intelligent, but at the same time, they're either really good with computers, or they're really good with mechanics. With a few guys bring the two together, that's the guy I want to focus on.
Yeah.
Because he will say, oh, that's a good tool, I'll buy it.
And they're few and far between these days. Yeah. Because they had no jobs. Their jobs were taken away.
How many Apple engines have you ever seen? Kids today want a night thing.
Correct. 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 Yeah, I agree. So, am I done?
You are totally done.
Early.
Seven minutes late. But
7 minutes late.
yeah, we were going to have a sing-along.
Oh, that's right. We were going to do a sing-along. I forgot about the sing-along. What were we going to sing?
White collar, collar.
Okay. Are you saying that we're done then? I still have the mic. Okay. I guess we are done. We will see you next month. Same time, same bat channel.